Hi and welcome back. By the end of this video, you should be able to describe a method to determine the specific heat capacity of a material, in this case, aluminium block. Before we start, have a go at this quick task. 3 measuring jobs, 3 missing instruments. Pause the video if you need some time. To measure temperature, we use a thermometer. To measure energy transfer, we use a joule meter. To measure mass, we use a balance. Keep these 3 in mind. They come up throughout the lesson. Specific heat capacity is the energy needed to raise the temperature of 1 kilogram of substance by 1 degree Celsius. Here, both copper and aluminium are heated by 20 degrees. Copper requires 2 units of energy to do this, while aluminium requires 4 units of energy but the same temperature rise. This means that aluminium has a higher specific heat capacity compared to copper. It takes more energy to heat up by the same amount. For the practical setup, you need to know all the instruments needed and their function. The aluminium block we're trying to investigate, the thermometer to measure the temperature, the immersion heater to transfer thermal energy into the block, insulation to reduce heat loss to the surrounding, the joule meter to measure energy transferred, a power supply unit to connect to the joule meter, a stop clock to measure the period of heating, and a balance to measure the mass of the aluminium block. To carry out the practical, first, we measure the mass of the aluminium block. This is 1000 grams. I'm going to write that down and convert it to kilograms later. Next, we insert the thermometer and then the immersion heater. We connect that to the joule meter and into the power supply. The equation gives us the 3 measurements we need to find the specific heat capacity. The energy transferred from the joule meter after we've heated for 20 minutes. The mass of the aluminium block, which is 1000 grams, but we need to convert it to kilograms. And then the temperature change, which is the final temperature minus the initial temperature. So let's say the starting temperature or the initial temperature for this block is 23 degrees. We write that down somewhere. And then when we have heated the block for 20 minutes, we're going to take the final temperature and then we can find the temperature change. Before taking the initial temperature, it's important to add a few drops of water into the hole of the thermometer to ensure thermal contact between the thermometer and the aluminium block. Next, you turn on your power supply and the joule meter and then start the timer for 20 minutes. After 20 minutes, the joule meter now reads 45,105 joules. The final temperature is 69 degrees Celsius. The initial temperature was 23 degrees Celsius. So the change in temperature would be 69 take away 23, which is equal to 46 degrees Celsius. The mass was measured as 1000 grams. To convert that to kilograms, we would divide by 1000, and that would give us 1 kilogram. Substituting these values into the equation, we have 45,105 divided by 1, which is the mass in kilogram, times 46, which is the temperature change. Solving this, we get 980.54 joules per kilogram per degree Celsius. The accepted value for aluminium is 900 joules per kilogram per degree Celsius. Our result is higher because of heat loss to the surrounding rather than heating the block. To reduce this, we use an insulator. This is a common exam question. How do you reduce energy loss to the surrounding? A lid, an insulator, or a less conductive container all work depending on the setup. We can now write a detailed method for the experiment. Number 1, measure the mass of the block using the balance. Number 2, insert the immersion heater and thermometer. 3, record the initial temperature of the block with the thermometer. Number 4, switch on the heater and start the timer. 5, after 20 minutes, measure the final temperature and calculate the temperature change. 6, measure the energy transferred using the joule meter. And then finally, number 7, use the equation C is equal to E divided by M times delta theta to calculate the specific heat capacity. Here is an exam-style question on finding the specific heat capacity of water instead of aluminium. It is the same method, just a different material. One thing to think through: how do you find the mass of water when it's sitting in a beaker? For a 6-mark answer, you want to explain exactly how the mass of water is determined, not just measure the mass. Pause and have a go, then we'll go through the answers. One hazard: hot water or the heater, both can cause burns. Now let's look at a full method of finding the mass of the water and completing the experiment. First, you measure the mass of the empty beaker on a balance, and to fill the beaker with water and measure the total mass. The mass of the water is equal to the total mass minus the mass of the beaker. Turn on power supply, and so the heater increases the temperature of the water. Note you have to take the initial or the starting temperature of the water. And then you take the final temperature, and then you can calculate the temperature change. You measure the energy transferred with the joule meter, and then you substitute into the equation to find the specific heat capacity. Like I said earlier, a level 3 answer must have a clear method of how to determine the mass of the water. One source of error is energy loss to the surrounding. How do we reduce this? You insulate the beaker of water, could add a lid, or you could use a less conductive material, like a plastic cup. You should now be able to describe a method to determine the specific heat capacity of a material.